The enthalpy change for a reaction is called the enthalpy of reaction, or heat of reaction. The value is associated with the balanced chemical equation as written. For example, with this balanced chemical equation for the combustion of butane, the enthalpy of reaction is negative 5,756 kilojoules. That means when 2 moles of butane combine with 13 moles of oxygen gas to produce 8 moles of carbon dioxide and 10 moles of water vapor, 5,756 kilojoules of thermal energy is released and transferred from the system to the surroundings. We can use the enthalpy of reaction just like a coefficient in dimensional analysis in order to convert from moles of a substance to energy, or vice versa. We can also have an enthalpy change for a particular process or reaction. For example, an enthalpy of combustion is the enthalpy change for the combustion of a fuel. It is often given in units of kilojoules per mole of the fuel. If we were given the enthalpy of combustion for butane, it might be stated as negative 2,878 kilojoules per mole. Notice that the enthalpy of reaction in our first example is exactly 2 times the enthalpy of combustion of butane, because there are 2 moles of butane in the reaction as written. Let's practice using an enthalpy of reaction in dimensional analysis. Our problem reads, calculate the heat in kilojoules associated with the complete combustion of 113 grams of butane, according to the following reaction. We'll start our dimensional analysis with 113 grams of butane. We can convert from grams of butane to moles of butane using the molar mass of butane. Then we can convert from moles of butane to kilojoules using the coefficient for butane in the balanced chemical equation and the enthalpy of reaction that we're given. Completing the calculation, we should get negative 5596 kilojoules.